Hi and welcome. In this tutorial, I'm going to discuss a transistor working as a switch, and we will try to control a load with the help of a transistor, especially NPN transistor. If we consider the characteristics of a transistor, we have three regions of operation of a transistor, which are known as cutoff region, active region, and saturation region. If we are using a transistor as an amplifier, then the transistor will be operated in the active region, but for switching action, we will operate the transistor in cutoff region and saturation region. In the cutoff region, the transistor will be completely turned off, and in the saturation region, it will be completely turned on. We need to remember two basic equations when we are dealing with the transistors. First one is the collector current, which is denoted with IC, and it is equal to base current multiplied by the gain of the transistor, which is also known as HFE. And the second equation is the required base resistance, which will limit the current to the base when we will operate the transistor as a switch. So the base resistance will be equal to the supply input voltage, which we will provide on the base, subtracting the base emitter voltage, which is generally 0.7 volt in most of the cases, and divided by the base current. For this tutorial, I am going to use the example of this 547 NPN transistor, and this is TO92 package with the first pin as collector, the middle pin as the base, and the last pin as an emitter. I will use the Proteus ISIS software to simulate the behavior of a transistor as a switch. For this, I need one transistor, which is BC547, then a resistance RES, and then search for LED red. I will use this LED as a load. Here we have this simulation model of BC547 NPN transistor. This terminal with an arrow is the emitter of the transistor, and this terminal on the upper side is the collector, and this is the base. The base of this transistor is of p-type material. We need a base resistance to limit the current. I will connect a ground to the emitter. On the collector side, we have to connect our load, which is an LED in this case, and here is the power supply for the load. It is 12 volt here. This transistor switch will act as a syncing device because we are connecting the source permanently to the load, and this transistor in between the ground and the load. Now if I consider this load required around 50 milliampere to turn on, then we have to get the exact value of this R1 so that we can get the exact value of base current to turn on this transistor in the saturation region. To find the base current and the base resistance, first if I consider I need 50 milliampere collector current, then the base current will be equal to 0.25 milliampere, and with the help of this base current I can find the base resistance equal to 17.2 kilo ohm when we are using a 5 volt signal at the base to turn on the transistor. So this is a non-standard value of a resistance. Instead of this value, we can use a 20 kilo ohm resistance. So in the simulation, I will replace this 10 with 20. Now we have 20 kilo ohm resistance on the base. We assume that this load will consume around 50 milliamperes. We have our 12 volt supply connected to the load. Now we need an arrangement here to provide a high pulse to the base of this transistor. For this purpose, I can connect a button to the base, and as we need a 5 volt supply, we add another supply here. Now if I run the simulation, the LED or the load is off, and if I press this button, this LED is turning on because through this push button this 5 volt supply is going through this current limiting resistance for base, and it is providing around 0.25 milliampere current on the base according to our equation, and this is driving this transistor in the saturation mode, which is allowing this load current to flow through the transistor. If I release the push button, it will stop the base current through this resistance, and Hence, this transistor come back to cutoff region and it will act as an open switch, so there will be no current flow and our load is turned off. I can replace this push button with the microcontroller or with any other logic circuit to control the transistor and the load. Here I am taking the example of this simple LED and resistance arrangement. I can also connect a motor, a relay, a buzzer or any suitable device which I can control with the help of a transistor. So in next tutorial we will go with the same arrangement, but we will control the different loads such as a relay or a buzzer. Thanks for watching the video and don't forget to subscribe the channel.